It's truly wonderful to have Mori Sensei with us today. And I'm going to... it's not up here. So, I'm going to talk about the robotic perspective. And as robotics is moving closer and closer to the human, the issue of social robotic and the social interaction between human and robot becomes very important. In fact, there is something very important Mori Sensei mentioned, which is the importance of movement. And I'm going to discuss how movement and understanding the movement of human is very important. Shape is critical, however, sometimes very simple shapes could produce with the proper movement if this video moves. Let's see if it can move. This is Microsoft. So just bear with it. So sadness could be conveyed very simply with an object that is performing a motion. In fact, there is a lot of work in this area that is being pursued in different universities. This particular one is coming from the University of Munich. So the challenge in robotics, as we all know here, is the fact that we really have now more than a few degrees of freedom. We have a lot of degrees of freedom to coordinate. We have many limitations in the motion of those degrees of freedom. And trying to coordinate all these motions is not easy. I mean, if we take a kinematic approach, we end up with uncoordinated motion that are very difficult to understand. This is a more coordinated motion, but still far from what we would like to see. The limitations make it that we reach singularities, and we will have difficulties with the coordination as well. If we look at the dynamics and the momentum and all the characteristics that we have in physics, it becomes really interesting. The motion, the dynamic motion is very, very important. Now, it's not only the dynamic motion that is important for the robot, it is the human motion, and as it happens, the human has much more complex actuation. So we have muscles, we have many muscles, and we have to deal with redundancy in the muscles, redundancy in the system, and all of that brings us to wondering how these athletes are able to perform those complex tasks and what is behind those tasks. So studying the human motion, capturing the human, analyzing, having models of the human model are very important for our understanding of how things happen. And we have made a lot of progress, in fact, in those areas, applying techniques from robotics to see how motion is taking place. And the main conclusion is that those models are subject specific. We have to just not go with the typical motion. We have to understand the mapping of that motion to the human, to the particular subject. So we talk about human motion atlases associated with specific person. So now, once we have that understanding, we can synthesize human motion, and we can guide those motions, and we can also map those motions to robots through different controllers that are produced from our understanding of the criterion and the strategies that are used by humans. In fact, here is a really nice example with fewer number of degrees of freedom. You can see the fluidity of the motion of this robot as it moves. The position of the eyes towards the object being manipulated is very, very important. And I think this is something that we really captured from the human. In here you can see the compliance is very important, following the human in that interaction. The robot is surprised. You can notice what is going on here. And as we go in more, oh sorry, I missed one. As we go to more complex things, like if we have contact and if we are interacting really with the environment, the problem is really challenging because we have to deal with reaction forces, we have to control these contacts, at the same time control the internal motion now that are limited by the constraints. And doing this in a way that is really human-like is very, very challenging. Now, this is only physically like and physically correct. This is another motion where we have slippage, we have to deal with the control of the contact and not to slip around those motions. So another domain that is being explored today in robotics is not only to take robots on the ground, but to take them in the large oceans, working like divers, especially in fragile environments like coral reefs. And we are exploring this. If we have, I have 1 minute. Okay, very good. So let me show you how robots can go further in performance. And one of the performance we tried to do was capturing an African dance, and you can see how bad the robot is performing. So I would like to thank you, Mori Sensei, for this opportunity to be with us to share your thoughts. And I'm going to finish with an illustration of that diver with music.